Operational definitions are important to any green belt because bad data looks just like good data when you get it into a spreadsheet. These become your first line of defense against making sure that bad data doesn't sneak its way into your project. Let's do a quick experiment. In a moment, I'm going to show you a picture and I'm going to ask you to count the number of blue shirts that you see. You're only going to have 10 seconds to look at this, so work quickly. Are you ready? It's coming your way in 3, 2, 1, here we go. Time's up. What's your number? Very good. Let's take a look at some results. I've done this same exercise in a classroom setting over 100 times, so I can tell you with experience that the results, if you were sitting in a classroom right now with a lot of other people, and we were to do a dot plot of what everyone's counts were, it would look like this. Before we go any further, let me ask you a quick question. In Six Sigma, who is your enemy? If you said variation, you're right. What would this look like if we had no variation whatsoever? You're right, it would be one column of dots. Everyone would give us the exact same answer, but they didn't. In this case, our data looks like this. Variation shows up in the spread of your data. In this case, over 50 people looked at the exact same image that you did, and they are all giving us different counts that range from 3 to 9. I'm willing to bet that your number is somewhere in this mix. Why did we get different numbers? We had no set of rules to go by for counting blue shirts. We didn't operationally define what we meant by shirt, nor did we define what we meant by blue. So do you suspect that if we went to the folks who said 3, 4, or 5, we might get a different definition from them than the folks who said 7, 8, or 9? I know that we would. When you have no rules established, people are left to come up with rules on their own, and they're going to come up with different rules for what a blue shirt is. Let's take a look. For example, did you count this gentleman right here? The reason I ask is his shirt is green, his jacket is blue. Should we be counting jackets? We were asked to count blue shirts. I'm not sure if jackets are supposed to be counted or not. What about this fellow at the bottom? That sure looks like a sweater that he's wearing, so I'm not sure if I'm supposed to count that or not. It's certainly blue, but I'm not certain if it's a shirt or not. Did you count this lady over here? Technically, when a female wears a top, that's a blouse. It's not a shirt. Should we be counting all genders or just males? Not sure. What about this fellow in the upper left? Did you count him? That's certainly a blue t-shirt, but does a shirt have to have a collar? Does it have to have long sleeves? Does it have to have buttons? We don't know what the rules are, therefore we don't know whether we should count this or not. What about this Magnum PI shirt here in the middle? It certainly has some blue in it, but is it enough blue to qualify this shirt as a blue shirt? Without knowing what the rules or the operational definition is, we have no idea. So what if we went away from a bad operational definition that's very vague? Just go count blue shirts. And we do something that's more specific. In our better operational definition, we're specifying the time frame. We're saying we're only looking at human beings. If you have an emotional support dog and that dog happens to be wearing a shirt for pets, we're not going to count it. Humans only. It doesn't matter their age or gender. But to operationally define a shirt, it has to have a collar and at least one button. To be blue, any part of its original design, including stitching, buttons, patches, or logos that are printed or sewn on, would be considered as well. The next bullet says that we're really only looking at shirts, not jackets or sweaters. And if someone has let's say a white shirt, but they have put something temporary on that shirt that's blue, like a name tag or a badge of some sort, that does not qualify the shirt to be blue. Also, if someone comes in with a white shirt, but they're carrying their dry cleaning with a blue shirt, that does not count either. And the last bullet point indicates that we're only going to count each shirt once a day. So if a person is coming and going multiple times and you've already counted them, you only count them once. Lessons learned about operational definitions over the years include this. Number one, you got to have them. You got to have them for every X and every Y. It doesn't matter whether you're counting things or measuring things. Every one of the X and Y variables in your study need an operational definition. Why? Absolutely bad, corrupt, bogus, evil, unusable data looks exactly like pristine, wonderful, usable data once you get it into a spreadsheet. You can't tell the difference. I can't tell the difference. This OpDef is your first line of defense against getting bad data. This means you have to create these definitions prior to collecting the data, not after, but before your team goes out and collects it. This allows you to communicate to your team, train them in this definition, dialogue with them, and make sure that everyone is following this definition and is very clear about it before you go collect data. Here's a harsh lesson learned. When you or I write down an operational definition, what makes sense to us may not make sense to someone else. Therefore, if you have an operational definition that in any way is open to multiple interpretations, it will be interpreted multiple ways. Therefore, you have to be as precise as possible. We're trying to get rid of ambiguity. Be as detailed as you can. If you want to use illustrations, you want to use pictures, videos, audios, clearly show people this is what a good one looks like, this is a bad one, count this, don't count this, here's a video on how to measure something. Whatever you can give as job aids, instructions, error proofing. Put on your failure mode and effects analysis cap at this point. What could go wrong with your measuring process and how can we bulletproof it? This is such an important topic that there is a separate statistical set of tools called MSA, that's Measurement System Analysis, that allow you to conduct a quick back office experiment with your measurement team, and it gives them a red light, yellow light, or green light to go collect data. It lets you know to what extent they are ready to go collect data based on these definitions. That's it for operational definitions. Good luck with yours.